All right, so yeah, what we do is we add the opposite. We add 3 to both sides. We get 5. And then we plug that back into the equation. Y equals negative 3x plus 5. With that said, the next question asks us, find both a parallel equation of a line and a perpendicular equation of the line. Of the line that represented in question 10. So this is the line represented in 10, right? So now I need to find a perpendicular and a parallel. And so that comes down to our notes. We have to know what does perpendicular mean, right? And when a line is perpendicular, right? When a line is perpendicular to another line, then that implies that the slopes are opposite inverses, right? So what that means is these two slopes, right? No matter how I have them, no matter where they are, one's going to be positive and one's going to be negative. And the rise and the run is going to be the same thing. Now, does it matter where we go through the point? I mean, I could go through this point right here, right? Even though that's where it goes through at 5, right? It goes through at 5. We found the intercept to be 5. Can I go through 5 with my perpendicular? Yeah, it doesn't matter what my intercept is on the perpendicular. All that matters is now my rise, right, becomes my run. So now when I look at this, I go up 1, and let me get this more perpendicular. Only as good as my art, right? So I'm going to go up 1 and over 3. Okay? And so those become perpendicular. So I'm going, sorry about that. So these two lines are perpendicular, they're right angles. So now my rise becomes my run, and my run becomes my rise. But the sign flips. Now this is a positive, whereas this was a negative. So my slope here for my y perpendicular is going to be 1 over 3x. And I can say plus 5, it doesn't matter. Or I can say plus nothing. Or I can say plus 10.
But that's the formula.
But that's the formula.
Can we please stop?
I'm recording and I can't stop.
I mean after.
After we record this.
Okay.
Okay?
So can we please leave that too, please?
Sure.
Thank you.
But then you won't get your double lines.
That's all right. We'll do that next.
Okay.
This is hurting my brain.
Yeah, it really
Okay.
is painful right now.
That's fine.
Can you? I can look it up. Never mind.
Well,
Go,
What
go.
does perpendicular mean again?
Perpendicular means that they are making a right angle. Okay? So the two lines are always making a right angle. And that's why their slopes are mirror images of each other. Right? Because when you're
Like a
perpendicular to it, you're the opposite. You're going in the opposite direction. They're going this way, you're going to go this way. But if they're going this way, you're going this way. Okay? So it's an opposite, but it's inverted. See? So it means that the rise and the run now becomes the run over the rise on perpendiculars. Okay? So all you do is, it's real simple. You flip it and you smack it. Okay? That's all you got to do. To make a perpendicular slope, you take the original slope, flip it and smack it. Boom. So if the m was equal to 2/3, m perpendicular would be flipped and smacked to be
3 over 2.
negative.
Got it.
Wait,
Okay.
wait a minute. 2/3 is positive,
Yeah.
so you have to
Make it a
the
negative.
opposite as a negative. I
Yes.
have a question,
Yeah.
and I think the tutor kind of didn't know what he was doing when he confused me. I mean, he knew
Sure.
what he was doing. He didn't mean
But
to
it just
confuse
confused, yeah, like I do sometimes.
If there's if there's a minus in front of a fraction, does that mean both of them are negative? Or can you have a negative
Oh.
3 over a
Yeah,
positive
see,
2?
when you have a negative, like this one, negative 3 over 2 is equal to negative 2 under 3, right? They're the same. And then that's also equal to negative 3 over 2. So let's use something we know to figure out what we don't know. Okay? This my favorite saying. I finally got it on tape. Okay, so figure out to use what you know to figure out what you don't know. Use numbers that you know that work, right? So how about 6 over 3 negative? Right? What is that? It's going to be negative 2, right? 3 goes into negative 6, negative 2 times. Okay. What is 6 over negative 3?
It's a positive 1/2.
A negative and a negative and a positive means it's a negative.
Oh.
3 goes into 6, so it's still negative 2.
Wait a minute.
And then what is negative 6 over 2 equal to? Well, it's negative, so this one's going to be negative. And what's 6 divided by 2? 3. Or what am I doing? I switched it, sorry. So it's negative 6 over 3. Let's use the same numbers.
How come I was seeing 1/2?
Well, we're just talking about what this is. We're not talking about the perpendicular.
Oh, okay.
Now, the perpendicular is going to be 1/2.
Oh, so my head was stuck.
Yeah, you were stuck on making it a perpendicular.
Okay.
That's all. But what I was trying to show you is that if the negative's on top, it's still negative, right? If the negative's on bottom, it's still negative. If the negative's on the outside, it's still negative. What if the negative's in both sides, the top and the bottom?
Then when you flip it, it's positive.
Yeah. Because think of that. What if we go down 1? We go down 1, but left. So that means I went down 1, but I go left 3. Minus 3. So rise over run tells me it's minus 1 over minus 3. But what is that? That's still 1 over 3.
Oh, 1 over 3.
Which is what this is, right? 1 over 3. It's on the same line.
It's just a positive. You just go the other way.
It's just going the other way.
Oh, because you're down, but then you have to go up and over.
Yes.
Got it.
Good.
Okay. One more thing. Give me one more second. What if the line? What if the line is parallel? This one's easier. What happens when they're parallel? What is it about the slopes? They never touch,
But they're
so they have to be
Is it congruent?
equal.
equal. Congruent is something we do in geometry. They're equal. Congruent is it means equal, but because they're different. They're equal but different.
Okay, I'll let it go.
These are equal. What we're saying is that M1 is equal to M2. But, and we say and, if I go through, I'm going to make a parallel line, okay? I'm going to make it with the blue. Okay? And so a nice parallel line would be like this. Right? Never touches, blah, 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 blah. Right? But if I go through this point, what happens?
That's not parallel no more.
No, it's not parallel no more. It's the same. It's the same line. Same lines.
Oh.
Same lines is not the same as parallel. right? Because the same line will have the same answers for both of them. And the parallel line will never have an answer for both of them. See how they're different? Parallel lines, the x's and y's for here will never work for this one.
What?
But the same line will always work. And a perpendicular line, or any line that crosses, only works when? When they cross. So they have the same answers, the same x and y right there where they cross. Okay? No matter where they cross, the two lines are the same answer at that point. So the one thing we have to know here is that the b's, b1 cannot equal b2. If that's the case, y parallel is going to be what? If they have to be the same, then what's my slope going to be? If it's parallel to y? The same, which is? Negative 3x. And then you can keep it at that, or you can say plus 4, or anything but 5.
As long as the intercept is different.
As long as the intercept's different.
Okay.
And so that's your number 11.
Thank you, it's 2 o'clock.
Oh.
25 minutes for 2 problems.
Come on, buddy. Woo.